Hello, everyone. My name is Ted Gudmundsen. I'm from Tamr, this company. I'm visiting from Boston in the United States, so please pardon my terrible American accent. I know that we're waiting on some pizza. Maybe since we're a bit behind, we can pause in the middle and eat some food if that works out. I'll look at Tim to give me the signal. I know there was a study that was very interesting of a parole board in Israel, and the prisoners who came to the parole board directly before lunch had like a 20% chance less chance of getting paroled than the ones who came right after lunch. So I'm very worried about a hungry audience judging me here, but please be nice. So who is here today? How many people are coming from big companies? Raise your hands. A few. How many people are coming from startups? Okay, quite a few. How many folks are very familiar with machine learning? A very machine learning heavy crowd. Okay. How many people have trained their own classifier? Okay, a very technical crowd. Good. Students, any PhD students or master's students here? No, all startups, okay. Good. Up until 6 months ago, I was working at a government lab. I was doing research, actually in physics, so I'm a recent convert to the IT world. And so I'm not very used to having slides that have been written for me by marketing, so I have lots of pretty slides, but please ask me questions. I don't want to talk about the business plan. I want to talk about how does the thing work, because that's what I'm most interested in. So if you're also interested in how does the thing work, good. Ask me your questions. I will start with a quick introduction to what Tamr is trying to do. So I should probably say something about the name, huh? In the US, the company started as Data Tamr, which is, what's the French translation?
Dompteur de données.
Yeah. Dompteur de données. By the way, everybody, this is Tim Kirk, also from Tamr.
The deal was I'm not supposed to talk.
He's the sales guy. Data Tamr was the original name, but of course, I don't know if it's true for startups here in Europe also, but in America, for a startup to be cool, it can't have all of its vowels. You have to take out the vowels. So we got rid of the E, and now we're at Tamr. The problem is that now in French it sounds a little bit like Tamr, which is a little strange, but that's why we're going to translate it into French. Okay, so what do? We catalog, connect, consume. We're really into data unification in the sense of bringing data that is all over an organization, especially messy data, together into a format that you can use. And so the three steps here are to understand what data you have, to try to connect that data, and then to do something that drives business value with it. I'm going to show you sort of two different demonstrations, the first about catalog, the second about connect. Our consume story is largely to partner with third parties. So we just put the data in a way that you can get to it from a third party. But I can go into that more later. We were just started in 2013. We're a very young company, as a large number of you, also from startups. Dr. Stonebreaker is coming out of MIT. This is based on research from MIT. Dr. Stonebreaker was one of the chief founders of Ingress and Postgres, and most recently Vertica. This is a man who spent his entire life working on making databases better, making them faster, making them more powerful. And he realized, he's in his 70s now, and he's realized as he goes out and looks at the way his databases are being used, that really the problem is no longer that they're not fast enough or not powerful enough, it's that there's so many of them, right? There's 100 databases that all have overlapping information, and to really unlock the value from those databases, you have to connect them. And so that's sort of the origin story of how he became interested in this problem. We get money from some people. I'm a physicist, I don't care. How do you unify data in today's environment? This is a very marketing-y slide. The answer is largely that you hire data scientists, or you get somebody who can program, and you have them, meet with the business users and iterate and go back and forth. And it can be a bit slow because you've got to bring these teams together, and mostly you have to write a lot of code to do unification in a smart way, problem by problem, right? The picture I have in my mind is, you've got spreadsheets, and you've got to map each column in each spreadsheet to the column that you want to map it to in the next spreadsheet, and then you've got to write some business logic to try to integrate the rows. It's complicated. We have a new and better way. We're going to use machine learning to try to make some of this faster than it was before, and I'll show you that in a sec. I would say that the main thing that we're trying to do is just make this process faster. Tamr is not magic. Those of you who work in machine learning, a lot of you, know that people are, oh, machine learning, it's amazing. The machine's going to think like, it's going to do magic. It's not going to do any magic. We will not come up with anything that you couldn't have done with enough time and enough programming. The hope is just that before, it really would have taken a lot of effort to do the integration, and now the integration is much faster. The use case here is that with Thomson Reuters, they took 6 months to integrate a new data source in. It was very complicated, lots of meetings, and we were able to get the same level of data quality in 2 weeks. So that's very marketing-y. What do we do here? We start with diverse data sources. We do data profiling, schema mapping, record deduplication, and we're using machine learning and expert sourcing for that. I'm going to just show you what this means, so we don't have to spend much time here. Okay, as I mentioned, there's two products I'm going to show you briefly. The first is Catalog. This product was just launched in beta 2 weeks ago, so it's relatively simple still. It's relatively new, and the best part is it's free. So we are putting this out there to the community without charging in hopes that you'll realize, not you startups, but you big company people, will realize how much data you have out there and how nice it would be to be able to bring it together, at which point you will then buy the next product, which is the Connect part. But here we'll just show you the catalog. You're welcome to go download this from your laptop, even while I'm talking. What are we doing here? We are, this data is around a real estate company. They are interested in doing some analysis on commercial real estate. So they have connected various sources here. Some of these sources are, this is really, let me just play for a minute here. This screen is so much smaller than the laptop screen in terms of resolution. It's funny. I'll do my best. So here we have CSV files. We have databases and individual sheets within those databases. We have XML or JSON objects. So semi-structured data is fine. And each box that you're seeing here is just one of these data sources. So one of the things that we can do is we can tag these data sources. tag is off the screen here, so I can't.
Maybe you can shrink it.
Yeah, that's a good idea. You're our savior. Thank you. Very good.
It's a slight PhD there.
Okay, so great. Now we can actually see the info on the side. So we can put tags on these things and just keep track of what they are. Here we can filter on tags. We can view things based on tags. Sure. We can see, if we just want to look at the commercial sources, we can see which of the sources have been tagged as commercial. And the goal here is not to do any manipulation, it's just to see what data is available across the entire enterprise. So we can, of course, change the way these boxes are colored or sized. You can change it so it's sized based on the number of rows of data or colored based on the number of columns of data, and so forth. So the next thing you want to do is you want to then take a look at what are the individual columns or what are the individual attributes here. And so we can just browse through these things. We can search quickly for what different things that have to do with address. We can see here that the biggest source is this, for commercial properties that have addresses, is this America commercial database. But actually the completeness here is only 31%. So at that point we can then write a comment to our colleagues, what is the matter with this data, right? And so it's a way of collaborating and sharing across data, making comments. This data does not live on Catalog. The statistics are being generated by the source and being pulled back to Catalog. With the, yeah, that's basically correct. And the goal again is just to have some sense of what kind of data is out there. Any questions about this functionality?
Yeah, I basically don't understand that.
Okay. How so?
Well, so when you're saying that this data doesn't live in Catalog,
right,
but it's connected to the Catalog, what do you expand? Or?
Yeah, sure. So if you have a database source, the data remains in the database. Each of these statistics, completeness, uniqueness, cardinality is a query. So it's translated into the query language of the local database, which then sends the metadata back. So it gives you the row count and the column count and all of these things, right, from the database. That's the short answer. The slightly longer answer is that with CSV files, in that case, we actually import it into something that you can query. I think this is actually on a Postgres backend. Do the query and then dump it again. So you temporarily ingest it in order to get the metadata out. But the data continues to live in its original place.
So how much work do you have to connect up these sources?
So, I mean, from your point of view, it's not at all, right? You just go to the new source here and say, I have an XML file or an Oracle database or a Postgres database or whatever it is. You can see our list is not terribly long since it's in beta and just came out 2 weeks ago. But I know the guys who are working on this, and in the next 3 months, their main goal is to make that list much longer. So that's coming.
Do you keep the data in the sources? Meaning to have a virtual database at the sources with metadata you describe? Or you integrate the data inside your own format?
The metadata itself?
No,
the data is kept in the source, yeah.
In sources, and you have a kind of virtualization to have access to these sources, if I understand.
That's right, yeah. Did I answer your question? Okay, good.
I see databases, I see JSON or XML files.
Yeah.
Assume things with query engines running on top of that already.
Yes.
So that means if you just have a collection of Parquet files on Hadoop, then you might not be able to connect into that to see what data quality there is. Or
Yeah, so could you, I mean, we'll often come with some, things may be stored with some metadata there, right, which you can pull out. But you're right, the team will have to be a little clever about how they crawl things like that where you may have diverse data sources.
yeah.
How about availability when data changes in the sources? How quick is it transferred? How is it transferred and updated?
That's a great question. To be honest, I'm not sure what the underlying functionality there is. My guess is that the moment you have to manually press refresh to have it go get that again. Are there plans to make that more automatic? Probably, but I don't know what they are. At the moment, I think it's manual. So, yeah, one more.
You said that you use machine learning for defining the link between database. Does it mean that I have to learn my model on my data, or is it learn on your premises?
I haven't gotten to the machine learning yet, so here there's no machine learning.
Okay.
This is a lightweight tool just to see the data, basically. You just want a graphical view of what you have. So, I'm coming. Okay, this is Tamr Catalog. Again, I encourage you to download it, to take a look. You know, the functionality is relatively simple, but I think it's useful just to get a sense of what you have, because you know, a lot of the people who we encounter in big companies say, I don't even know what sources are out there. So I think there's a need for this.
So this is in beta test now.
It's in beta now, yeah.
And then when will be the commercial release? Or the, let's say, the stable release?
Yeah,
or-
sure. To be honest, I'm not sure a date has been set. They just got the beta out 2 weeks ago and have been really pushing for that, so probably they're not sure. Okay, so let me switch over to Connect as a product here. And Connect is about, now that you know where your data is, the idea with Connect is that you need to stitch it together. So let me start, I like to be more specific. So let me start with 2 use cases that we've worked on in the last few months. So one is television shows. We had a major television studio come to us and say that they wanted to analyze the ratings, number of people watching for their shows. So this is an external data source, the ratings. They buy it from Nielsen in the US. And they have ratings at the time slot level, something like September 25, 2015, 2200. On the channel BBC America, you have your Star Trek, the name of the episode, 23,000 viewers, right? In order to do analysis, you need to roll this data up to the episode level, and the episodes need to then be rolled up to the series level, so that you can do the analysis. Of course, the studio has their own list of series. They have a list of things that they're producing, their own list of episodes, but it doesn't line up, right? It's something along, here's an example. It's going to be something else featuring actors, no abbreviation. A bit tricky. So there's a fuzzy match here. There's also a granularity problem here as you're trying to integrate this. I'm not going to give you I'm just sort of setting up the problem here. Here's another problem that we've been working on recently. General Electric is one of our first and biggest customers. They want to know how much they buy from whom. And they want a list of their suppliers. And General Electric is a very siloed company. It's almost different companies. GE Aviation, that makes planes, almost doesn't speak to GE Appliances and Lighting. They're like separate entities. So they have the same data about who they're buying things from, but they keep it in different formats. They have different names, different conventions. Beyond that, matching up companies in and of itself is kind of a difficult problem. IBM Client Center Brussels at this address is actually the same company as IBM Corporation, but if you just put this into a string match, you're in a lot of trouble. There are third-party sources that help, like Dun and Bradstreet, but of course those also have to be integrated. So, some things that help here. There are signals in this data that matter. For example, in general, when you buy something, you have a contact, a human contact at the company that you're buying from, and if you parse out the domain name from the email address, the @ibm.com, right? This is actually a very good signal for what company someone is coming from. But the thing that is difficult is to pull out that signal and to make sure that you know which, to come up with a way of analyzing this data that gets to the important signals, and that's where the machine learning will come in. So these are two examples of problems that Tamr Connect is really designed to help with. And what I want to say about this kind of problem is that there's no good lookup key, right? When I say I'm interested in data integration, I don't mean it in the same sense as someone who does ETL. ETL is also about data integration, but there it's about moving data around, and the unification of it is the easy part. You have some good lookup key, you just match on that lookup key, right? That's not the problem I want to solve. I want to solve the messy data problem, where all I have is a name. Oftentimes that's because it's from an external source, or it's from different silos of the organization, or there's been a merger and acquisition, something like this. So Tamr is after this messy data problem. Okay. Any questions before I start? I'm going to actually show you the Tamr Connect product now. Are you with me so far? Okay, awesome. So in this particular example, this is an automotive retailer. They've got a lot of sources about customer. They want to ask questions about their customers. Their customers are individual humans who buy cars here. So you can see we've got any given source. These are tables. A source is usually a table. This one is a CSV from marketing. Things like family name, residence, town, city, maybe a key number here, province, and so forth. Note that this key is specific to this source and doesn't line up with any other source. You've got some internal sources. Again, that one is for marketing. You have some ERP systems, if that means anything to you. You have some external sources, such as a credit score or something like that. You want to bring all of these things together. So let me show you the end result. Here's what we're trying to create. We've got a cluster of records. They come from different sources. They have different identifiers. They're all about this woman named Christine Roberts. But the data's messy. In some cases she's Robert, other cases she's Roberts. We have a nickname, Chrissy Roberts. Social security number is there sometimes, but it's sparse. Date of birth is in different formats. This is all very typical. Different email addresses. And yet Tamr has been able to bring these records together there's some connection somewhere in the data between these different records. And Tamr's been able to sort of find that connection and bring the records together. So that's where we're going. Now, how did we get there? The answer is that sort of in two parts. First we did schema mapping. Then we did this record matching. And I'll show those in two separate pieces. So here I'm showing you all of the different attributes, all of the different columns in all of those 122 sources. Obviously it's a bit hard to read here. There's 1,749 of them. So let me just select one of my sources. Here are the attributes in that source. Here are the columns. And you can see that I've already done the mapping for some of these. Now two of them I haven't done, residence number to street number and town city. I have not mapped either of these. And Tamr is making a suggestion here for how you should map these columns together. This one's very straightforward. Town city to town city, it's the same name. This one's a little bit harder. Residence number to street number. Just looking at the name of the attribute isn't enough here. But Tamr is very... That's a little too small, but okay. You can see the strength of Tamr's suggestion. It's giving me 3 bars out of a possible 3 here. It's very firm on that suggestion. So what's happening here? Tamr is not just looking at the name of the column, it's also analyzing the data in the column. So if it's numerical data, it's looking at the standard deviation, it's looking at the mean, If it's text data, it's looking at if it's a single word, or if it's a sentence, or if it's a paragraph. It is going further and saying what are the most common values here. So if you see a lot of male and female, it's going to know that this is a gender column and map it to the other things that have a lot of male and female. So it's looking for common values, it's looking for distributions of the data, and using all of those signals, it makes some suggestion on how your schema should map. So if you have 3 databases that you're trying to bring together, this is not very useful functionality. I mean, it's nice, but it would take you, what, 5 minutes to do it with 3 sources? It's not very important, basically. But if you have 100 sources, it's pretty helpful. And actually, we have a few pharmaceutical companies where they are trying to integrate study data across thousands or tens of thousands of studies. Now, it's extremely useful, right? Because when you get up to this level of trying to integrate thousands of tables together and get this one schema, you really don't want to have to click column by column and try to map these things by hand. Of course you can, and there's a way to override the suggestion, and you can map by hand, but Tamr's suggestions get better with the more data it has. So this is the schema mapping. This is getting the columns together so that you eventually end up with something that looks like this. Each of these is one of my unified columns, a unified attribute, and you can see that I've mapped 106 columns from the 122 original databases into the first name column. Any questions? I still haven't gotten to the machine learning part, but
I guess you have to deal at some point with uncertainties here, because you have data which sometimes match, sometimes you have some orthograph which is not the same. Can you a bit elaborate about it? How do you deal with that?
On the certainty, basically?
Yeah.
Yeah, I don't think it's very fancy. Well, it depends, it can be fancy. Each of these algorithms, there are actually 5 of them. Numerical distribution, name of the column, most common values, that's actually several signals, is going to give you some certainty that these 2 things are the same. It'll give you a similarity score between the data in the 2 columns, right? Then the question is, how do you combine them? Actually, we do have a bit of a machine learning algorithm there, such that if the system finds that one algorithm, maybe the distribution algorithm, is more reliable than the others, it will start to rely on that more and more often. But that's a little bit technical. The easy answer is just it's giving you some distance function.
So that's more schema mapping, so you have to define which tables should map each other.
Yeah.
And you also provide foreign key discovery.
This sort of takes the place of foreign key discovery. So rather than, you can hook up 2 tables in a primary key foreign key relationship, but oftentimes, but you have to do it manually. Oftentimes what you want to do instead is you just say, hey, this column here is the primary key for this column that's the foreign key. If I bring them together into the same unified attribute, then the records will end up, the information in those 2 rows will end up in the same record ultimately, which is usually what I want with a PKFK lookup. So we sort of play around the PKFK thing in most cases. If you absolutely want it, yes, you can set it, but you have to set it manually. Does that answer your question?
Yeah, basically, if you don't give any table as input, you are able to distribute automatically different foreign key, primary key in different tables. But no, you have to explicitly give the tables you want to map to.
If you want the primary key foreign key relationship to exist in Tamr. But the alternative is that you just bring in, you let it will notice, right? It will say, hey, all of the values in column A are the same as all the values in column B, and it will suggest that they come together into the same unified attribute, which isn't quite the same as a PKFK, but it's similar, and that is automatic, right? So you get some of that functionality.
Is it actually copying the data then?
Yeah, great question. Yes. In this product, unlike in Catalog, the data is actually moved to we are moving the data locally.
Which format?
The one I'm demonstrating on is in Postgres. We also have an Oracle version, and right now they're working very hard on a Hadoop version. I think that ultimately is where the product is going.
So can I paraphrase it as a join across databases?
No. The schema mapping, let me show you the next part, because I think you'll see the full power coming up here. Okay, let me now show how we are. Again, the goal here is to get the records matched up next. And so let's talk about how we want to do that. Okay, so imagine the question of whether or not two records are the same or different. Here are two records. Is it the same guy? Jeffrey South. We know his birthday is March 30, 1987. He lives on Hudson Street. We have some bad typos, but to the human eye, this appears to be the same human being, the same customer. So we would say that this is a match. The goal here is to try to train Tamr using machine learning to recognize that this is in fact a matching record. Of course, you can do this programmatically. You can say, okay, if last name matches and first name matches, that's probably a match, but that's not quite enough because there are common names. So then I need address or phone number. But then sometimes the same person changes their name, or there's a typo. But if I have email address, that's good. But you get all these conditional cases, right? It can be very complicated. Here, we're going to write no rules. There will be no programming involved. This is entirely something that a business user can do. So the business user just trains the model by answering questions. Are these the same or are they different? Now, many of you work with machine learning. Of course, what we're doing here is we're building a training set of data, right? But we're just building that training set through this GUI. We're having the user input their training data record by record, basically. So we say, yes, this one is a match. Mark it as a match. Go on to the next set. Here we've got a guy named Ike Carpenter. Again, messy data, but yes, this is a match. We mark some number of points here. That number depends on the use case, of course, but on the order of 300 to 500 in a lot of use cases, maybe up to 1,000. Usually past 1,000, you don't get much benefit. The first 100 points usually take me about a half hour because I have to go one by one. The second 100 points, Tamr will be mostly correct, and so I just review the ones at the edge. That one takes me about 10 minutes. So, I can get up to, 500 points or 1,000 points. I can train a model in an afternoon here. So if you compare that to the time it will take you to write out these rules and then check them and correct them and write them and check them, it's really a much faster process. And so this is the part where we say that machine learning really speeds up how quickly you can integrate these data sets. One other sort of nice piece of, this is no fancy machine learning, but a nice piece of GUI, is that in this, it's often the case that you don't know the answers to questions. Or, especially in a big company, the person who is building the model doesn't know as much about the data itself. So in this particular example I'm giving you, of course it's easy. All of us know what is first name, what is last name. But much more common is you're doing a parts case, and widget 1547-W, is it the same as widget 1457-W-R? And you look at the record and you say, I don't know, what do these letters and numbers mean, right? It's impossible to tell. So then you need to, really the person you need is the widget engineer, whoever is the guy who really knows about widgets. So here you just hit the Ask Expert button. You say, I don't know the answer to this question, but Greta McIntosh is my widget expert, so I will ask the question of her, and you can ask the expert there. That will send her an email. She signs onto the system and just says, yes, it's the same, no, it's not the same. Again, you're trying to find a way to get the training data that you want across a big organization. What questions do you have?
You were talking about unified data columns. So are they automatically decided, generated, or are they also manually?
Yeah, great question. If you have a unified schema, of course you can import it to start with. If you don't have a unified schema, normally I start with the first source and say everything in the first source counts as master, and then if I need to map in new columns from the second one, I can do that sort of on the fly. So either way.
Okay, if you ask for an expert opinion on to find out what part it is, for example.
Yeah.
And you said that an email is sent to that person. So how does the system, the web-based system, integrate the response from the expert? So you send an email to that person, and what do? Do they get a link in their email, a link to the URL, where they then have to click on the URL and then they give an answer, or is the email sent to the system? Is it done via the URL, or via an email back to your system?
Yeah, it's a good question. The email really says log on to Tamr, you have to answer some questions. They log on. So they're not answering in the email, they're logging onto the system. We have different users who can sign on. And when it comes back to the main screen, this column actually says experts. You can't see the full word, but there, if you send that question out, it will say experts who responded 0 out of 1. When the person responds, it will say 1 out of 1. You can click on it and say this person said it's a match, right? So, so if there are ways to make that automatic, but usually if it's a close call, you want to check what the person said, basically.
So you're supposed to train a model yourself, but isn't there, I might have missed something, but is there an initial model? Because you have sort of cold start problem. If you're at Accept with more than 2 million customers and you present 2 random records, the chance of them being the same is extremely low. Yeah,
great question. Yes, there's a lot of stuff going on behind the scenes. So let me say 2 things. First of all, this idea that there's actually 2 steps happening behind the scenes. You're talking, the first thing that you mentioned is sort of the n-squared problem, right? You have 1 million records here and 1 million records here. You put them together, the number of possible matches is 1 trillion, right? Add in, you don't have to increase those numbers very much before it's computationally impossible to compare, just to compare them, right? Never mind get the right model. So behind the scenes, Tamr has a DNF. It's a blocking algorithm. So it just says, let me just look at 1 or 2 fields that are important and use those to eliminate almost everything. You can see, here I've only got 2 million questions that have come through those 122 sources. So 99.99% of the data was eliminated right away. And Tamr is actually pretty smart about guessing what's important. It basically looks for columns where there's some matches, but not very many. So it will quickly pick up here, without my training it, that name is actually going to be a pretty good field. It will never do something like gender, because obviously, you will never get, you won't eliminate nearly enough possibilities, nor will it pick something where it eliminates everything, right? So it's pretty smart about that. Of course, it does make mistakes. You do have to train it some. So that's a starting answer, at least. That problem is also how this happens in this DNF, the blocking thing, is also how it happens in a small amount of time, because you can actually group records together so that you don't have to compare every record. You can say, hey, these 100 records all have the same characteristics in these fields that I care about. Therefore, I will only compare 1 representative record out of that group of 100, and it will stand in for the other 99. So there's some tricks behind the scenes here to speed this up, because getting it to happen, at an amount of time that a user will handle is, of course, part of the trick here.
But really, I'm trying to imagine, for instance, address. You have address and you have some kind of product A, then you have address and some kind of product B.
Yeah.
Then at some point, he will start linking products that have nothing to do with each other, because he will find address matches, okay, we will put that one together, and then we put another column. In one-to-one relation, okay, I kind of get the idea, but when you get one too many and you start linking everything together, then everything will be lost, I think.
Yeah, so that's why you have to have the classifier. Of course, you have to choose distinct points also.
Yeah,
you have to say these 2 things.
At one point he will be sure, and he will say like, yeah, address, it's a good classifier, so I just start linking, and he will link everything together, and maybe that's something you don't want it to do.
Yeah, for sure. And then you will, if you start to see these giant clusters from on address, in fact, so the system will generate questions for you, and those questions are useful questions that helps it to train the classifier. That's how you're able to train with so few questions, is because it's choosing the questions in an intelligent way. But in fact, there's some functionality here, if I can get it on screen. No, I can't.
So Ted, I'm going to give you the sign with the pizzas.
Oh, okay.
So,
I'll wrap up here. There's a way to search for a particular field. You can put a filter on. So you can say, I want to see everything that the system has marked as match that has the same address. Then you can look through them and say, no, these top 10 are not matches. Retrain, or these top 500 are not matches. Retrain with these 500 new points, and very quickly the system will realize, oh, hey, I made a mistake here. Right, so there are ways, of course this does happen, right? It's going to make mistakes as it learns, but there are ways to quickly correct. Now we're very motivated for a few questions. Anything else? So the last step here is the step that I've already showed you. That's the clustering, right? We have a bunch of pairs that have some similarity. Now we have to do something like if A is similar to B and B is similar to C, then A, B, and C are one group. That's what you're seeing here is one of these clusters. Of course, it's not quite as, anyone who does computer science knows it's not quite as simple as that. And so there's some algorithms behind the scenes on how you do that clustering effectively, but that's the last step. Okay, so I will invite you come up, pepper me with more questions, especially if they're technical, hard questions that I might not know the answer to. Ask me over in the corner, and otherwise, let's eat some pizza.